We all know that limiting molar conductivity is a molar conductivity of a solution when the concentration approaches to zero. What is the chemical formula of the rust? The chemical formula of the rust is iron oxide and it is represented as Fe2O3 X into water molecule. So this is a diagram of standard hydrogen electrode, that is SHE. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in this session, we are going to discuss with another unit called Unit 3, Electrochemistry. So let's see how the weightage will be distributed for this unit. So from this unit, we can expect 10 mark, okay. So the questions will be goes like this. In a part A, the question number 4, part B, the question number 18 and 19, and in the part D, the question number 38 will come from this unit. So we can expect one mark question, two mark question, and also we can expect one 5 mark question. So remember, in this 5 mark question, the 3 marks is always meant for the numericals, okay. It is based upon the E0 of the cell. So we'll see how the questions will be raised in the part A. We'll see how 1 mark questions will be raised, similarly with the 2 mark as well as with the 3 mark question. We'll see how the question will be arises in the 1 mark. The first question will be goes like this. Define the limiting molar conductivity. So we need to define what? Limiting molar conductivity. We all know that limiting molar conductivity is a molar conductivity of a solution when the concentration approaches to zero, or it is defined as limiting molar conductivity when the molar conductivity of a solution whose concentration will be become a infinite at the dilution. It is said to be limiting molar conductivity and it is represented as inverted V0. Okay. Next, state Coleridge law of independent ion migration. The limiting molar conductivity of an electrolyte can also be represented as the sum of individual contribution of anions and cations of the electrolyte. Now we have understood that what is a limiting molar conductivity. Suppose if I say it is a limiting molar conductivity of the sodium chloride, okay, solution, it is obtained by limiting molar conductivity of the sodium ion and the limiting molar conductivity of the chloride ion. The sum of these two, it is said to be the Coleridge law of the independent migration of the ion, and it is obtained from the limiting molar conductivity of each cations and anions. Okay. State the Faraday's first law of electrolysis. So either the direct statement like the Faraday's first law of electrolysis or the Faraday's second law of electrolysis can be asked. Okay. The amount of chemical reactions which is occurs at any electrode during the electrolysis by a current is proportional to the quantity of the electricity which has been passed through the electrolyte either through the aqueous solution to the molten state. That is said to be the Faraday's first law of electrolysis. So how much of the current you pass through the electrolyte, both are proportional to each other. Next, coming into the second law of electrolysis, the amount of a different substances liberated by the same quantity of electricity which is passed through the electrolytic solution are proportional to the chemical equivalents by weight. So during the electrolysis, how much of the quantity of the electrolyte which has been liberated out, which are equally proportional to the quantity of the electricity which has been passed to the electrolytic solution by weights. What are fuel cells? The galvanic cell which are designed to convert the energy of combustion of fuels like hydrogen, methane directly into the electrical energy, they are said to be fuel cell. Give a method for the prevention of or preventing of rusting. We all know that rusting can be prevented either by oiling, painting, galvanizing, either by varnishing also or metal plating also. Name the gas which has been liberated at the anode during the electrolysis of molten sodium chloride. We know that anode, especially the chloride gas will be released out because in the molten state, the sodium chloride, when it is electrolysis, electrolyzed, it gives rise to the sodium ion and chloride ion. This anions are get liberated at the anode. Which gas it is? Chloride gas. Okay. What is the chemical formula of the rust? The chemical formula of the rust is iron oxide and it is represented as Fe2O3 X into water molecule. We'll see with the 2-mark question how the question will be arises from this unit. Mention any two factor on which the conductivity of an electrolytic solution depends. The conductivity of an electrolytic solution, it always depends upon an electrolyte, that is the nature of electrolyte, and how much quantity or the concentration of the electrolytic solution you are taking. That these two factors are very important to determine the conductivity of a electrolytic solution. One is nature of the electrolyte is important, okay, and another one is the concentration of the electrolytic solution. Next, what is the effect of dilution on the conductivity? Give reason. What happens to the effect of dilution on the conductivity? So, if you dilute the electrolytic solution, what will happen to the conductivity? Conductivity will become decreases with increasing in dilution. Why? Because as you dilute the sodium chloride, for example, you have taken a large container, to this you have added sodium chloride crystal and you have made the solution of sodium chloride. Now again and again if you dilute this solution, the formation of sodium ion and the chloride ion will become more and more dilute. Once the cations and anions have become more and more dilute, obviously the conductivity will get decreases. Because of the number of ion per unit volume will be decreases. That is the reason if you dilute the solution of electrolytic solution, obviously conductivity will be decreases. What is the effect of dilution on molar conductivity? So see, molar conductivity is different from the conductivity. So as you dilute, molar conductivity will get increased with increasing in a dilution. This is mainly because the total volume of the solution containing 1 mole of the electrolyte solutions are get increases. That is why, even though if you dilute the solution, molar conductivity will be increases. Why it is increases? Because in the molar conductivity, we have taken 1 mole of an electrolyte. If you dilute also, their conductivity will become increases. Hope you all understood now. Next, name the gas which has been liberated at the anode and cathode when aqueous solution of sodium chloride is electrolyzed. Okay, what will happen? If you take the aqueous solution of sodium chloride, okay, and if you place the 2 electrode and now if you electrolyzed at the anode, always liberated the chlorine gas, at the cathode hydrogen gas will be liberated out. Okay. Like this, the question will be asked in your second PUC examination. Next, draw the NEET label diagram of SHE. This is a 2-mark question. Okay. And write a symbolic representation and write the half cell reaction. So, here you need to write what? SHE diagram, that is standard hydrogen electrode diagram. So, this is a diagram of standard hydrogen electrode, that is SHE. Okay. So write a beaker, then write an electrode, okay, that is a single electrode, hence it is also known as single hydrogen electrode also. And you need to show the cations and anions which has been formed, that is a positive metal ion and negative anions, and you need to show the potential differences, that is delta, and also you need to show the half cell reaction. How to show the half cell reaction in SHE? The platinum electrode which has been introduced, so that the PTS divided by hydrogen bar H2. So hydrogen gas will be maintained at 1 bar pressure, and with the hydrogen with the aqueous solution of 1 molar, and the E0 value of SHE is 0.0 volts. Okay. So this is a value you must know, and you must know the symbolic representation of SHE. So either they can ask you to write the SHE diagram, sometimes they'll ask you to write the SHE symbolic representation, these equation, and you need to know the half cell reaction along with the E0 value. Okay. Next is calculate the limiting molar conductivity of calcium chloride. Given that limiting molar conductivity of the calcium and is around 119.0 Simon meter square per mole, and also 76.3 Simon centimeter square per mole respectively. So here they have given the calcium and the magnesium, the limiting molar conductivity they have given. We need to calculate what? Limiting molar conductivity of calcium chloride. Okay. So it is obtained by sum of cations plus limiting molar conductivity of the anions. Correct, no? So what is the value they have given? It is 190.0 plus 76.3 Simon centimeter square per mole. So limiting molar conductivity of the calcium chloride is 195.3. Like this, they can ask you to calculate the limiting molar conductivity by giving any aqueous solution. Okay, here they have given the calcium chloride. Instead of that, they can give you the sodium chloride. You need to put the cations and anions, then you need to count it, the limiting molar conductivity. Just by summing up these two values, you will get the limiting molar conductivity of the respective solution. Okay, next is 3-mark question. We'll see how to solve the numerical based upon the E0. Okay. Calculate the value of delta G0 at 298 Kelvin for a cell reaction. So here they have given a cell reaction of 2 Mg plus 2 Al3 plus, which gives us to the 3 Mg2 plus 2 Al. Given E0 of Mg is around minus 2.36 volt and E0 of the aluminum is minus 1.66 volt, and Faraday values they have given. So we need to calculate what? E0 of the cell first. It is obtained by E0 of the aluminum minus E0 of the magnesium. So it is minus 1.66, 2.36 minus 2.36. So it is minus 1.66, minus into minus plus 2.36. So minus into plus, it is again minus 0.70 volt. This is E0 of the cell. Okay. After this, you need to calculate what? Delta G0 value. That is, delta G0 value is equal to minus N E0 into F. Correct, no? Minus N. How many number of electrons are involved here? 2. Magnesium are losing 2 electrons. Since there are 3 magnesium, 2 3 is 6. So 6 minus 6 into what is the E0 value? 0.70 into what is the Faraday's value? They have given 96,487 coulombs. Minus 405.245 kilojoules. So this is a G0 value. So first you need to calculate the E naught of the cell, then you need to calculate the delta G naught of the cell reaction. Okay. Hope you all understood. For doing the cell reaction E naught value, you will get a 1 mark, and calculating the delta G naught value, you will get a 1 mark, and placing the correct formula, you will get a 1 mark. Next, calculate the EMF of the cell in which the following reactions will be taking place at 298 Kelvin. So, nickel plus 2 Ag plus give rise to the nickel 2 plus 2 Ag. So, E naught of the cell they have given, that is 1.05 volts. So, we need to calculate what? EMF of the cell. Correct, no? So, EMF of the cell was given by E naught minus 0.0591 divided by N into log of nickel divided by Ag. So, how many Ag will be there? 2. So, it is, what is the E naught value they have given? 1.05 minus 0.0591. So, how many electrons are losing the nickel? Nickel are losing 2 electrons, correct now? So, it is 2 into log of, what is the concentration of the nickel they have given? It is 0.160 they have given. And what is the concentration of the silver? It is 0.002 whole square. So, now if you do it, you will get 1.05 minus 0.0591, 0.0295 into log of, if you multiply this and if you do the division, you will get 40,000. Log of 40 you need to calculate, 1.05 minus 0.0295 into 4.6021. Now, if you do this subtraction, you will get 0.914 volts. So, this is the EMF of the cell. This is how, for placing the correct formula, you will get a 1 mark. For the substitution and for the correct answer, you will get a 1 more mark. Okay. So, totally you will get a 3 marks for this numerical. So, hope you all understood. See the reaction and see that how much the concentration they have given and place it in a formula. Next, calculate the equilibrium constant of a reaction. Equilibrium constant means Kc we need to calculate. Correct now? So, they have given a cell reaction where copper and silver were reacting, and copper loses its 2 electron where silver which is accepting 2 electron, and E naught value they have given. So, E naught value of the cell was given by, E naught of the cell is equal to 0.0591 divided by N into log Kc. Correct? What is the E naught value they have given? 0.46 into 0.0591 divided by how many electrons are losing the copper? 2 into log of Kc. Now, if you do cross multiplication, you will get 0.46 into 2 divided by 0.0591 into log Kc. Or if you take the Kc outside, anti-log of 0.46 into 2 divided by 0.0591. First, you get the values for this and find out the values of Kc. So, it is the anti-log of 15.5932. So, when you are finding out the anti-log, always remember, you need to say before the decimal how much of the numbers which is given, it is goes as a 10 to the power of 15. So, you need to find out the anti-log of 59 under 3 and you need to add the 2. Okay. Then, you will get the values of 59. Anti-log of 59 under 3 is 3.92 into 10 to the power of this 15 will becomes as 1/5. Okay, this is a equilibrium constant value. It is a Kc value. This is how we need to calculate the equilibrium constant. Remember, for writing this formula, you'll get a 1 mark, and for substitution, you'll get a 1 mark, and for finding out the antilog and for putting the correct value of Kc, you'll get a 1 mark. So total it is 3 marks. So hope you all understood with the types of numericals which have done from the electrochemistry. Remember, either EMF of the cell can be asked, sometime the delta G naught value can be asked, sometime equilibrium constant can also be asked. So 3 types of the formula and their substitution and their simplification I have explained. Hope you all understood with the 3 types of numericals which I have done from the part D. So I'll come back with the next unit. Till that, take care, be safe. Thank you.